everyone, today we're looking at Module 4, Lesson 20 and 21. And we're going to start with Lesson 20, which says every line is a graph of a linear equation. And the two key points for this particular lesson says any non-vertical line is the graph of y equals mx plus b, where b is a constant, as well as students can write a linear equation from a graph. So remember in lessons 18 and 19, we drew the graph based on the linear equation. Now we're going to write the equation based on the graph. So here's an example. I'm going to draw a quick axis here with y ranging from 3 to negative 3 and x ranging from 1 to 7. And then I have a point on 6, 1 and 0, negative 3. I use those 2 points to create my line. And now I'm going to look at my question. It says, given the line, what is the equation? So what can I observe on this line? I can observe the y-intercept. So when I look at that graph, I can see that I have a point on the y-axis at negative 3. So b equals negative 3. I can also find a second point, so one that's on a really nice cross-section of my grid paper. I don't want to point with a fraction because it's just going to make things more difficult, but I see a point at 6, 1. So I'm going to use the coordinate 0, negative 3, which is the y-intercept, and 6, 1 to find the slope. I can do this by looking at the graph and counting the vertical distance over the horizontal distance, or I could use that formula that we started to derive the other day. So I can use the coordinate of the second y value minus the first y value over the second x value minus the first x value, and I get that fraction of 2 over 3 as my slope. When I put my slope and my y-intercept together, I have an equation. Y equals 2/3 x minus 3. This should be the equation of my line. What I could do is pick another random point and just check and make sure that it's a solution to that line. So that point there was 3, negative 1. When I plugged it in, I get negative 3 equals negative 3, so my equation is in fact true. Just thinking about the slope formula again quickly. Remember that you have to identify a first coordinate and a second coordinate so that you know that you're subtracting your y2 minus y1 and then x2 minus x1. That's the same as saying the distance of QR over the distance of PQ, just like we did in our last video. Moving on to Module 4, Lesson 21. I'm going to focus on some facts about graphs of linear equations. With my main idea being that students determine the equation of a line from a graph using slope and y-intercept. So in the previous example, we found the equation of a line just using 2 random coordinate points. Now we should be able to use what we know about slope and y-intercept to also find the equation of a line. So I'm drawing a graph here with a y that ranges from positive 4 to negative 3, and then an x that ranges from about -3 over to -5 or 6. I have 2 points, one at -1, 4, and one at 4, 1. And I'm drawing my line L. So I can use 2 points to find the slope, and then I can solve for b. Because my b value, my y-intercept, doesn't really look like a nice even point on my graph. But I have 2 coordinate points that when I use the slope formula, so 4 minus 1 over -1 minus 4, where that first equation is my first set of coordinates, second equation is my second set of coordinates, I get a slope of -5 over 3. So if I substitute in a coordinate point, like 4, 1, for my x and my y values, now I have 1 equals -3/5 times 4 plus b. If I solve for b, I end up with 1 and 12/5 equals b, or 3 and 2/5 equals b. And when I check my graph as to where my line intersects the y-axis, it looks like it could be pretty accurate, 3 and 2/5. So I'm going to say my linear equation for this graph is y equals -3/5 x plus 17/5 or 3 and 2/5. Those mean the same thing. I wouldn't write a mixed number in a linear equation though. I would always write an improper fraction. So don't forget, you can find a linear equation in several different ways. So we could use 2 points, we could use 1 point and slope, or we could use slope and y-intercept. And it's just about being creative with the numbers and manipulating that equation.